Alrighty, today we're going to do 8.6, which is trigonometric equations. Before we do these, we're just going to remind ourselves of kind of SOHCAHTOA stuff. So when we originally learned SOHCAHTOA, we learn it as the sine of the angle is opposite over hypotenuse, but we also learned it as the y value over the radius, and the hypotenuse and the radius are always positive no matter what, but this number up here and the y value are not always negative or always positive. Cosine is adjacent over hypotenuse, which is x over r, and then tangent of theta is opposite over adjacent, which since opposite is y, this would be y over x. So with that in mind, we are going to figure out which quadrants these ratios are positive in. So what we're going to do first is look at quadrant 1. So this one is Q1. And you can see down below here, we're going to circle which ones actually end up being positive when we're in quadrant 1. So let's just make a triangle, a general triangle in quadrant 1. So we graph some angle that ends up in quadrant 1. We drop down the triangle. The x value that's right here would be positive, and so with this y value. Both of them are positive. So since the hypotenuse is always 1, or if we're on the unit circle, if we're not, it's the radius and it's always positive. Because x, let's start with sine. Y over r are both positive values, so the sine is positive. Cosine is x over r, so that would mean this is x over r, so that's positive. And then tangent is y over x, and a positive divided by a positive is still a positive. Another way to help you remember that is that if you were to plot a point in quadrant 1, the x coordinate and the y coordinate would be positive. So in quadrant 1, all of our trig functions are positive, and that's because of this guy right here, because all x's are positive, all y's are positive, and when we do any division with positives, they stay positive. Okay, so let's see what happens. What's going to be positive in quadrant 2? So we're going to just draw some generic angle in quadrant 2, and then we drop it down to make our triangle. The y and the r are positive. Radius is always positive, but this y is above the x-axis, so it's also positive. But look at this. This is to the left of the y-axis, so that makes that x negative right there. So which two functions involve x? Cosine and tangent, right? So again, in quadrant 1, all of them are positive, none of them are negative. But when we move to quadrant 2, where all points are negative x's and positive y's, the sine one is going to be positive because positive y and r is always positive, stays positive. But cosine is x over r, and negative x over positive r is negative, so cosine is not. And then tangent is y over x, so that one is also not. So in quadrant 1, all of them are positive, but in quadrant 2, it's only sine that's positive. So we're going to put an S there just to help us remember that in quadrant 2, that's what goes on. Now if we go down and make our general triangle in quadrant 3, our points are negative and negative, so the x is negative because it's to the left, and the y is negative because it's down, but r is always positive no matter what. So if we're looking at what is positive in quadrant 3, because this one just says positive ratios, sine is y over r. Negative y over r would be negative. Cosine would be negative x over r, which is also negative. But tangent is negative y over negative x if we're in quadrant 4. So tangent is actually positive in quadrant 3. That's what I meant to say. This is quadrant 3. So tangent is positive in quadrant 3. Let's do our last quadrant, which is quadrant 4 down here. We're drawing some general triangle, connect it to the x-axis. R is always positive. In this case, the x is positive and the y is negative. So when we look at our ratios, because the y is negative, the sign is going to be negative, but the x over r is still positive, but the tangent is negative y over x, which means that it's not positive. So in quadrant 4, cosine is positive. So really what this means also, just so you know, is that when I say sine is positive in quadrant 1 and quadrant 2, its reciprocal is also positive. We're not really going to be dealing with those, but I wanted to make you aware. When you flip a fraction, it's not going to change its negative or positive sign, but just in the future. And cosine is positive in quadrant 1 and quadrant 4, and tangent is positive in quadrant 1 and quadrant 3. So what you notice here is if we write these in order, we have A, I'm going to move it over, A, all of them are positive in quadrant 1, so this is how we're going to help remember it. S, so that would just be sine. Tangent in quadrant 3. And then cosine in quadrant 4. So our way to help us remember the order starting with quadrant 1 is all students take calculus. So quadrant 1, all of them, sine and students both start with S, take and tangent both start with T, and calculus and cosine both start with C. Okay? So the reason why we need to know these is because now we're going to be solving trigonometric equations. When we solve trigonometric equations, we are solving for the angle. So look at this equation right here. The sine of x equals 1/2. That right there is the angle. And we're taking the sine of that angle and it's going to give us the ratio of 1/2. So we've labeled this right here and given you steps for how to solve these. So step 1, draw the unit circle and label with all students take calculus. So all students take calculus. That's what step 1 is. Obviously we're not drawing a circle because it would be painstakingly annoying to have to do that over and over again. But 2, determine which quadrants the angles are located. So this is a sine one, which means sine is y over r. So the sine is the y value. So this means that really what we have is, if we're on the unit circle, 1/2 over 1, right? Because you notice that 1/2, that comes from a 30, 60, 90 triangle. And since it's positive, which two quadrants will it be located in? Well, first it's going to be in this one because they're all positive in that one. So again, the 1/2 is positive. And then because we're dealing with sine, it's also positive here. So we won't find the angle in quadrants 3 or 4 because sine is negative in those quadrants. So then the next thing we have to do is make our special triangles. Sometimes we deal with quadrantals, but if the special triangle is got the sine to be 1/2, it must be a 30-degree reference angle, because that's what's always opposite 1/2. And then step 4 is identify the angle. So this one, starting from 0, is just 30 degrees. And then this one is going to be 90 plus that 60. Or if you prefer, you can just do 180 minus 30. And we get 150 degrees. Okay? So these are our two answers for these guys right here. Alright, moving on. We're going to go up to the tangent one. Actually, we're not. We're going to come back to that one because tangent's funky because it's y over x. So we're going to go to this one right here. The cosine of x equals negative 1/2. Step 1, draw your unit circle and label it with all students take calculus. Step 2, figure out which quadrants you're in. This is cosine. So cosine is x over r, which means that we're negative 1/2 over 1 if we're on the unit circle. So the x coordinate has to be negative. So that can't occur here because they're all positive, or here because this is where cosine is positive. This is where our x's are negative. So we're going to have to do this. Okay, so the bases of both these triangles are negative 1/2 because that's the x direction. That would mean that this is negative root 3 over 2 and this one is positive root 3 over 2 because it's above the x-axis and this one's below. But the question is, what is the angle that gets me here? Well, if this is root 3 over 2, then opposite that has to be a 60-degree reference angle. So it's going to be 90 plus that little 30. So to get to that triangle, I would have to graph a 120-degree angle. What about the other one? Again, we know this is 60 degrees. So to find that angle, it'd be 180 plus that 60 degrees. So that gives me 240 degrees. Alright, so let's go back up to this one right here. The tangent of x equals 1. So with this one right here, it's a little different, so in a way. So first we're going to start with this, and we're going to do all students take calculus. And tangent is y over x. So we need y and x to be the same thing so that we can get it to simplify to 1. So right now we can write it as 1 over 1 because you can always make that a fraction, but that's not, that would be the radius of our unit circle, but that's not necessarily the actual special triangle. So remember, our special triangle ratios are root 2 over 2, root 2 over 2, and 1. And then for 30, 60, 90, 1/2 root 3 over 2 and 1. So we need this piece to be equal, because if I do y divided by x, or if I have to switch those, they'll still both be 1. So this right here is going to be part of a 45-degree angle. So with that in mind, which quadrant will it show up in? Well, all of them are positive here, and since this is positive, sine is positive there, which means tangent and cosine are negative. And same thing here, that means sine and tangent are negative. So it's going to be in these two quadrants. And remember, I want the ratio of y over x to simplify to 1. It doesn't have to be 1 right when it starts. You guys have definitely done tons of math with these where it doesn't start out at 1, but it simplifies to 1. So just keep that in mind. It just has to simplify to 1. And in this case, the only special triangle we're going to get out of these that simplifies to 1 is the 45, 45, 90. So we know this is a 45-degree angle. So this is x equals 45 degrees. And when I come all the way around to here, that's 180 plus the 45 degrees, which makes that 225 degrees. Alright, so there's our first three. We don't really have that many from this point forward. What you're going to want to do when you're doing trig functions is just like everything else, isolate the trig function. So when I say isolate the trig function, in problem D, that means get that by itself, the sine of x. So if I wanted to get the sine of x by itself, the first thing I'm going to do is subtract 10. And then the next thing I'm going to do is divide both sides by 20. And I get negative 1/2. So now I have it isolated. So now I'm going to do all students take calculus. And this is sine, which is y over r. So that means it's going to be negative 1/2 over 1 because the r is always positive. And it's sine and it's negative, so this is where sine is positive and this is where all of them are positive, so this angle must be ending up in quadrant 3 and quadrant 4. So we know these are 30-degree reference angles because of what they're opposite. So the first one's going to be 180 plus 30, which is 210 degrees. And the second one is either going to be, however you want to do it, I'm going to do 360 minus 30. So that makes my math easier. So that's 330 degrees. All right, let's try the next one. Uh-oh, I see a radical. Don't freak out. Remember our patterns up here? They have radicals in them. So we just need to keep these in mind. So 30, 60, 90, 45, 45, 90. We're going to see radicals. All right, so first thing I'm going to do is isolate that cosine x. This piece right here by adding root 3 to both sides. So I get 2 cosine x equals root 3, divide by 2, divide by 2. The cosine of x equals root 3 over 2. Oh, which triangle is that a part of? A 30, 60, 90. And it's opposite a 60-degree angle, but be careful because this is cosine and cosine is adjacent. So this is going to be, all students take calculus. Cosine is positive all and cosine, so not here, not here, and cosine is x over r, so this is root 3 over 2 over 1. So that would mean that it would look like this. There's 1 and there's 2. Because the base is the bigger one, we're actually opposite. That's our sine values right there. So the inner angle here is 30 degrees because even though we're dealing with cosine, cosine's adjacent. So that's adjacent to the 30 and opposite is 1/2. So our two angles are 30 degrees and 330 degrees again. Alright, moving on to the back side. Alright, negative tangent x plus 1. So for that one, you're just going to isolate the tangent x. Okay, so subtract 1 from both sides and then divide by the negative 1. So subtract 1. Negative tangent x equals negative 1, divide by negative 1, divide by negative 1. The tangent of x equals 1. Tangent, I remind myself, is y over x. And when I look at those values, remember these two, either one of these can be x or y. But this one always has to be r. And same thing with this. When we do root 2 over 2, root 2 over 2, and 1, either one of these could be x or y, because those are sides of the triangle, but this guy is always r. So which triangle is going to give me y over x is equal to 1? It doesn't matter how I divide these two, which one's on top and which one's on bottom. They're never going to equal 1 when I simplify. So it has to be this triangle right here. So, anywho, all students take calculus, all because that, tangent, because it's tangent, and then because I'm doing the 45-degree triangle, I'm drawing my triangles like that. So I know this is 45 degrees. So then this angle is going to be 45 degrees. And then when I come over here, it's 180 plus 45, which is 225 degrees. Alright, next one. Cosine of x plus 2 equals 2. Alright, subtract 2, subtract 2. Cosine of x equals 0. Alright, cosine of x equals 0. Ms. Wolfman said all students take calculus. But here's my two special triangles right here. and there's no 0 anywhere. Cosine is x over r. So in order for this to be a special triangle, since r is always 1, the x would have to be 0, but in our special triangles, the x's nor the y's are ever 0. So what that leads us to is our quadrantal. So I'm going to label these points because that's what we do with quadrantals. And we just said the radius is always 1, so which two values on this unit circle are the x is 0? So the x coordinate is 0 there, so that's at 90 degrees, and then it's also 0 all the way down here at 270 degrees. So really there's not an infinite number of answers. There's a finite number of answers that we can get for these, so it's either the special triangles or the quadrantals. Okay? We're going to come back to h. Right now we're going to go to I. We need to isolate the sign of x, so then you divide both sides by the square root of 2. Okay, so we have 1 over root 2. Look right here. None of these have a radical in the bottom, right? So what we need to do to be able to use those is rationalize. So now I get the sine of x equals root 2 over 2 when I rationalize. So another way to write this is by writing it like this. Now I see which triangle I'm going for. I'm going for the 45, 45, 90. So all students take calculus. It's sine. Sine is y over r, so that's going to be root 2 over 2 over 1. So that's a 45-degree angle. Doesn't even matter what these other guys are with sine, because we always label our angles by opposites, not adjacents, so that works out. So this first one is 45 degrees, but the next one is you have to go to 90 and add another 45, or go to 180 and subtract 45. So that gives us 135 degrees. Okay, the last one is definitely the trickiest one that we have. So right away, my red flag goes, okay, I see a root 3. I go to look at my special triangles. Which one has a root 3 in it? It's the 30, 60, 90. So I'm like already saying this is the triangle I'm working with. It has to have 30 and 60 degree reference angles because this doesn't even have a radical 3. And also the cotangent x is already isolated. So always make them fractions, and cotangent is x over y. Or, if you prefer, you can just do the tangent of x equals 1 over root 3. It's up to you. Remember, I like having my radical in the numerator, but we'll see how it goes. So, all students take calculus. Cotangent is tangent's reciprocal. If we flip fractions, it doesn't change the sign. So even though this doesn't have a cotangent in it, because it's all sine, tangent, cosine, we still can follow the rules of tangent. So it's going to be these two. Okay, and then we have a root 3 over 1. So if our x equals 1/2 and our y equals root 3 over 2, then x over y. And why did I pick these right here? Because those are the two options for x and y when there's a radical 3. That would be 1/2 over root 3 over 2, which copy dot flip, these cancel. That gives me 1 over root 3. Which is root 3 over 3. This says cotangent equals root 3, not root 3 over 3. So it can't be this situation. So let's take a look at if we put x as root 3 over 2 and y as 1/2. Then when we do x over y, we get root 3 over 2 over 1/2. And when we copy dot flip, The 2's cancel and we get root 3. So this is our winning situation where the x's are root 3 over 2 and the y's are 1/2. And if that's the case, our reference angle ends up being 30 degrees. So once I know that my reference angle is 30 degrees, I get 30 degrees for that, and then this one is going to be 210 degrees. And that's it.